Hi, welcome to the 1-4 Graphs of Proportional Relationships instructional video. In the last lesson, in 1-3, I gave you a table of values and I asked you two questions. Is it a proportion? And if it is a proportion, what was the constant of proportionality? In this lesson, I'm going to give you a graph and I'm going to ask you the same two questions. Is it a proportion, and what's the constant of proportionality? These two graphs are perfect examples here. In order to be a proportion, a graph has to meet two criteria. The first criteria is it has to be linear. It has to make a straight line. The second criteria is it must pass through the origin, or the point 0, 0. Okay. This little guy over here, it is a straight line, and it clearly passes through the origin, 0, 0. This one, so this one's proportional. This one over here, he is a straight line, but he doesn't pass through the origin, right? So this one is not proportional, or non-proportional, if you like your really long words. Proportional. Okay? Moving on to our first example, a rabbit challenges a tortoise to a race. The table shows the distance that the tortoise moved after 0, 1, 2, and 3 minutes. Determine whether the number of feet the tortoise moves is proportional to the number of minutes by graphing the relationship on the coordinate plane. Okay? So here we have the point, this would be the point 0, 0. This is the point 1, 6, 2, 12, and 3, 18. So it means after 0 seconds, the tortoise has moved 0 points. After 1 minute, the tortoise has moved 6 feet. So we're going to go 2, 4, 6 feet, right there. After 2 minutes, the tortoise has moved 12 feet. 2, 4, 6, 8, 10, 12. And after 3 minutes, the tortoise has moved 18. So it'd be 16, 18. Now, forgive this line. This is not going to be straight. This is really hard to draw, these straight lines on here. But the question is this a proportional relationship? Well, yes, it is. It passes through 0, 0, and it was meant to be straight. So, yes, the relationship is proportional. Moving on to the check. In a pack of snacks, 1 piece has 5 calories, 2 pieces have 10 calories, and 3 pieces have 15 calories. So we want to go ahead and graph the number of calories, starting with, of course, 0, 0. If you have 0 snacks, then you have 0 calories. So you would put the point 0, 0. If you have 1 piece of candy or 1 piece of a snack, that's 5 calories. Well, here's 1 piece of snack, and this is numbered every 2, so 5 calories is going to be in between 4 and what would have been 6 here. 2 pieces would have 10 calories, so that would go there. And 3 pieces would have 15 calories, which would be just shy of 16 here. Drawing a line through all these points as straight as humanly possible. Is this proportional? Yes, it is proportional. Because it passes through the origin and it forms a straight line. On page 33, we go back to the tortoise and the hare. A rabbit challenges a tortoise to a race. The table shows the distance that the rabbit moved after 0, 1, 2, and 3 minutes. Again, they want you to determine if this is proportional by graphing these points. So at the 0 minute marker, the rabbit has traveled 0 feet. After 1 minute, the rabbit has traveled 8 feet, which isn't very impressive considering he's a rabbit. I can go 8 feet in 1 minute. But after 2 minutes, the rabbit still has only gone 8 feet. You remember the story, the rabbit took a nap. After 3 minutes, the rabbit has traveled 15 feet, which would be about here. Now, this does pass through the origin, but what you'll notice is this is not linear. right? It's not a straight line. So this is not proportional. It's not a straight line. Here, you knew we were going to get around to savings accounts eventually. We have a savings account, and it looks like the savings account starts with $10. So we're going to graph the 0.010, which right away tells us this is not a proportion. Okay, but I'll go ahead and graph the rest of the points. 112 would be here, 214 would be here, and 316 would be here. And it is a nice straight line, very nice straight line, but it's not proportional because it doesn't pass through the origin. Now, the second part of this 1-4 section is I'm going to ask you to find the constant of proportionality. So remember I said I'd ask you two questions. Is it proportional? And if it is, what's the constant of proportionality? This little diagram here shows you that you can pick any single point on the line and use it to find the constant of proportionality. In this example, the constant of proportionality is 5/1. But notice that each point led us to 5/1. But how did we get there? Well, let's just start with this point here, 210. 210 is a point on the graph. It's right here, 210. It's this little guy right here. Well, the first coordinate is always our x, and the second coordinate is always our y. Here it tells you though, when you're wanting the constant of proportionality, you want to put the y over the x. All right. So we take the y number 10, and then we put it over the x number, which is 2. Now remember, we're going to a unit rate because a unit rate is the constant of proportionality. To get a unit rate, we need a 1 down here. How do we get a 1? Well, we divide it by itself, but we also have to divide the top. 10 divided by 2 is 5, and 2 divided by 2 is 1. And see, this is where they're getting their 5/1. So the constant of proportionality is 5. Okay. So here we have an example. I really kind of hate this example. I think that this is kind of wonky how they did this. They gave us the point 531. Why would you do that? Why couldn't you just give us 530? No, they had to give us 531. And then this is the point 1062, even more fun. Whatever. And then they've done the work for us over here. Okay, so what they're showing you is this is the x and this is the y. And remember, with the unit rate or constant of proportionality, you put the y over the x. So you would put the 31 over the 5, and then you would divide the top and bottom by the bottom number to get a unit rate, which results in 6.2/1, which is what they're showing you here. Okay? That's the constant of proportionality for that graph. Okay, so now we have Brianna decides to save money each week for her family vacation. Use the graph to find the constant of proportionality. Okay, so we can use any of these points. The one thing I do need to tell you is you cannot use 0, 0 to find the constant of proportionality. Every proportional line has the point 0, 0, and you can't use it because it would tell you that the constant of proportionality is 0, which makes it not a proportion. Okay, so we're going to have to use a non-zero point. If we were to take the point 240, all right, 2 is our x, 40 is our y. We're going to write this y over x and then divide top and bottom by the bottom, which gives us a constant of proportionality of 20/1. So when it just asks for the constant of proportionality, just give it the top number, 20. And it says the constant of proportionality means that Brianna is saving $20 each week. You could have used this point also. You would have gotten the same result. You would have started with 80/4. But if you divide both of those by 4, you end up with 20/1. It wouldn't have mattered what point you picked. All right, and the last little section here is they want you to be able to tell them what the points stand for. Okay, what is the point really about? So here we have a graph. We have a field trip. The school's going on a field trip, and this side represents the number of students going on the trip, and this side represents the number of teachers going on the trip. All right, so they're telling you the point 00 is the point at which no students want to go on the trip, therefore there will be no teachers needed. Okay, so 00 means no teachers, no students. 125 means that you need one teacher for every 25 students. Okay, one teacher, 25 students. If you wanted to talk about the point 4100, that means you need 4 teachers for every 100 students. Okay, so the point 125 means that for one teacher there are 25 students. This also means that the constant of proportionality is 25 and the unit rate is 25 students for every 1 teacher. Now they want you to tell which of these is correct for this graph. Okay, if you want to pause this and see if you can figure this out yourself, there are 3 in the list that actually that do apply to this graph, but if you want me to just tell you how to do it, I will. Remember, to find the unit rate, you just need any point on the graph. So if I take this guy here, this is the point 1, 0.5. Well, this is your x and this is your y. To get a unit rate, you put y over x. And notice here we have 0.5. So the unit rate is 0.5. A proportion can never have a unit rate of 0. Now down here, we just kind of have to read our graph and figure out which one of these are true. This says for each smoothie, it costs $1.50 for every 1 ounce. Well, here's $1.50, and here's 1 ounce. This does not fall on the graph at all, so that's not right. For this one, it says it costs $2 for every 1 ounce. So $2 for 1 ounce, that's not on the graph either, so that's not right. For each smoothie, it costs $1 for every 2 ounces. 2 ounces is $1. Look at that, right on the graph. So this one is true. And for each smoothie, it costs $2 for every 4 ounces. 4 ounces, $2. Yep, that one's right also. And then this last thing, it's asking you to find the unit rate that's in this little table here. We have Michelle and Angelo, and they're participating in a school fundraiser. The number of items each student sells after 1, 2, and 3 days is shown in the table. Which ordered pair represents a unit rate for the number of items sold per day? Okay, so on day 0, they have sold 0 items, which means both of them have the point 00. So far, they could both be proportions. After 1 day, Michelle has sold 3 items, and Angelo has only sold 1. After 2 days, Michelle has sold 6, and Angelo has sold 4. And after 3 days, Michelle has sold 9, and Angelo has sold 5. Now, you could graph these on a piece of graph paper and see which ones make a straight line and which one doesn't. Another way you can tell is a straight line always increases at a constant rate. All right? So if we're looking at the rate of increase from here to here, this was an increase of 3. From here to here, this is an increase of 3. And from here to here, this is an increase of 3. That's increasing at a constant rate, so this is a straight line. But if you look at Angelo, to go from 0 to 1 is an increase of 1. From 1 to 4 is an increase of 3. And from 4 to 1 is an increase of 1. This is not a straight line. Therefore, Angelo's numbers are not even proportional. Now, we're only looking at Michelle's, okay? And they want to know which one of these is a unit rate. Well, one way I could write this to make it simple for you is I could write these as ordered pairs. We have 0, 0. We have 1, 3. We have 2, 6. And we have 3, 9. Now, if the first number is x and the second number is y, and we write this y over x, which one of these would give us a 1 as we're supposed to have? We have to have a 1 in the denominator for it to be a unit rate. Which one would give us a 1 here? Only 1, 3 does that, because you would have a 3 here and you would have a 1 here, which gives us a unit rate. Okay? So when you answer this in McGraw-Hill, it's going to give you a parenthesis, a box, a comma, another box, and the end parenthesis. you would type the 1 here and the 3 here. So that's the point. And the last example in this video would be this one. The heights of 2 plants are recorded after 1, 2, and 3 weeks. The data are shown in the table. Which ordered pair represents a unit rate for the number of inches grown per week? Okay, so it's kind of weird here. They have 2 columns for time in weeks. I'm not sure why they did that. But first of all, we can see that they both have the 0.00. So that checks. But is one of them not linear? The rate of increase from here to here is an increase of 5. From here to here is an increase of 1. And from here to here is an increase of 1. This one's not linear. So we cannot use plant 1. It's not proportional. So now we're just focused over here on plant 2. Increase of 3, increase of 3, increase of 3. This one's linear. It does pass through 0, 0, so it is a proportion. But which of these points would represent a unit rate? Which one, when I put in the y over x format, would give me a 1 here? Where is x1? Right here. So again, this is the exact same answer as the last problem. You would answer it the exact same way. 1 here, 3 here. And I think that brings us to the practice problems. It does, and the practice problems are covered in another video. So that is all I have for you now. Let me get this paused, and thank you for watching. If you have any questions, please feel free to reach out.